Did you know that 71% of Earth's surface is covered by water, which means only 29% of Earth's surface may be inhabitable? Of this 29%, around 33% is desert, while 24% is mountainous. A report few years ago highlighted that 95% of world's population lives on just 10% of the land. In our previous video, we looked at connecting everything everywhere. If we look at the connectivity provided by terrestrial mobile networks, just under one third of the landmass is covered by mobile coverage, regardless of the generation of the technology. This implies that roughly 90% of Earth's surface has no connectivity from terrestrial mobile networks. This is where satellites can provide connectivity directly or indirectly. But that's not all. Satellites are our friends in the sky and they can do a lot more. Keep watching to find out more. Welcome to another tutorial from the TechKnowledge Technology Stories series, targeted at youth looking to understand how technology has been evolving and how it will evolve further. In part 1, we looked at the way technological progress has made things smaller, faster, cheaper, and much more, while in part 2, we discussed the different connectivity options available to connect various devices, gadgets, and appliances to the internet. We saw how everything that can be connected will eventually get connected by some type of connectivity technology. In this video, we will examine how humans are taking the help of advancements in satellite technology to solve the problems of today and look for possible solutions in the future. Let's get started. Before we begin, let's understand the different types of satellites and their orbits. Historically, the most common satellites in use were the geosatellites. GEO stands for geostationary or geosynchronous Earth orbit. These satellites were designed in such a way that they remain above the same point on the ground. These satellites are tasked with monitoring missions, tracking the weather, and other remote sensing tasks, as well as being important communication satellites. As these satellites are far away, the latency, which is the amount of time required to send or receive data, is quite high. Hence, the use of geosatellites can be a bit challenging for any task that require low latency communications. MEO or medium Earth orbit satellites have historically been used for GPS and other navigation applications. As they are much closer to Earth as compared to geosatellites, they can provide lower latency communication satellites that could be used for providing broadband to the end users. The new generation high throughput satellites or HTS were designed for providing high data rates and have gained popularity over the last few years. Finally, we have the LEO or low Earth orbit satellites that are all the rage at the moment. As they are reasonably close to Earth, they can provide very low latency as well as provide direct connectivity to end devices outdoors. The popular Starlink satellite internet is provided by LEO satellites. If you were wondering how far these satellites are as compared to planes, here is a picture depicting this. You can also see the altitude of UAS or Unmanned Aircraft System and HAPS or High Altitude Platform Station as compared to the planes and satellites. Before the popularity of video streaming over broadband, they were generally broadcast via satellites. Direct Broadcast Satellite or DBS, which is also popularly known as Direct to Home or DTH services, transmit TV and radio over satellite that can be received by a dish or a receiving antenna and can work with a set-top box to relay the TV and radio channels on TV. This picture from Eutelsat shows different ways in which TV distribution works. The satellite direct to home follows the pink arrow as shown here. Here is another view of a satellite direct-to-home broadcasting system. The satellite dish on the left is generally a huge one, which is located at the Earth station. The dish on the right is not too large, and you have probably seen some outside homes. This is one of the largest satellite antenna located at Madley Communication Centre in UK. Apparently, it's so large that you can drive a BMW Mini through the hole in the center. You may also have used the satellite view in Google Map. Most of the high-resolution imagery of cities is in fact aerial photography taken from aircraft flying between 240 to 460 meters, while most other imagery is from satellites. The same is true for Google Earth. The images from different sources have been combined using software to make it appear seamless. The pictures and satellite images are regularly updated, and you can view the map over time once the images are updated. Navigation is another area that is very reliant on satellites. You may have your favorite app like Waze or Google Maps, but they all rely on the satellites to find your exact coordinates at any instance of time. The whole navigation concept became possible when the GPS or Global Positioning System project was launched in the United States in 1973. GPS satellites fly in medium Earth orbit at an altitude of approximately 20,200 kilometers. Each satellite circles the Earth twice a day. The satellites in the GPS constellation are arranged so that users can view at least 4 satellites from virtually any point on the planet. The location accuracy of GPS-enabled smartphone is up to 4.9 meters. The accuracy degrades in built-up areas. Recently, other countries and regions have started to launch their own GNSS constellations. You can see on the screen Galileo from EU, GLONASS from Russia, and Beidou from China. The accuracy of location can be improved by combining signals from different GNSS constellations. There are too many applications of GNSS to list here, but the main ones are highlighted on the screen. There are a couple of references that can be viewed in the slides for further reading. We have already looked at the different orbits of satellites. These multiple orbits, multiple bands, and multiple beams is allowing us to create a revolution in satellite communications. 5G has allowed native connectivity to satellites, either for backhauling or for direct access. Many device manufacturers like Apple, Samsung, and Huawei are also using proprietary solutions to relay emergency messages in case of an emergency where the user is outside of mobile network coverage. 3GPP, the standards body for 3G, 4G, 5G, and the future 6G networks, is working on improving satellite-based communications, which are referred to as non-terrestrial networks or NTN in the latest standards. The final topic we are going to discuss is called EO or Earth Observation. EO involves the use of satellite-based sensors and instruments to monitor and collect data about Earth's surface, atmosphere, oceans, and other features. The European Space Agency or ESA has some nice pictures and videos that it has captured using its Earth observation satellites. Earth observation satellites capture information in various forms, including images, measurements, and even spectral data. The satellites are equipped with sensors that capture data from a distance without direct physical contact with the Earth's surface. These sensors include cameras, spectrometers, and radar systems that can capture images, measure temperature, humidity, and other environmental parameters. This data is valuable for a wide variety of applications, including scientific research, environmental monitoring, disaster management, agriculture, urban planning, and more. Earth observation satellites monitor changes in the environment over time. This includes tracking deforestation, urban expansion, changes in land use, and alterations in natural habitats. Such information is crucial for conservation efforts and sustainable resource management. Satellite data is essential for weather forecasting and climate monitoring. Satellites provide information about cloud cover, atmospheric conditions, sea surface temperatures, and other factors that influence weather patterns. These data helps meteorologists make more accurate predictions. Earth observation satellites play a crucial role in monitoring natural disasters such as hurricanes, earthquakes, floods, and wildfires. They provide real-time data that can be used for early warning systems and to coordinate emergency response efforts. Satellites help monitor agricultural activities by providing information on crop health, soil moisture levels, and land use changes. This data assists farmers in optimizing crop management practices and improving overall agricultural productivity. Satellites are used to study and monitor oceans, seas, and coastlines. They provide data on sea surface temperatures, ocean currents, and maritime ecosystems, contributing to our understanding of climate patterns and the impact of human activities on oceans. Satellites used for Earth observation are often part of larger constellations or programs dedicated to monitoring and studying the Earth's environment. The data collected is typically made available to scientists, policymakers, and the public to support informed decision making and promote environmental sustainability. Here are some of the references useful for anyone wanting to study this topic further. These slides will be available on 3G 4G. Please look at the description of this video to learn more about where to access them. This is all we wanted to cover in this video. As you would have noticed, satellites do a lot of things and they are our friends and helpers in the sky. Hope to see you on our channel again soon. Thank you and have a good day.